All right, example 24, the function f is defined by f of x is equal to 4x squared minus 12x plus 13. So function f is defined by that, where x is greater than or equal to 3 over 2. So more than likely, this is my x is equal to minus h. More than likely. We're to sketch the graph of f of x and hence sketch f inverse of x. All right, if it's a quadratic graph, I need the minimum turning point. I can do h is equal to b over 2a. I can do this. I didn't have to. Which is equal to minus 12 over 2 times 4 minus 12 over 8. So h is equal to minus 3 over 2. And minus h is equal to positive 3 over 2. All right. I could do that. I could find k as being equal to f of minus h, which is the same as saying f of 3 over 2. Maybe this wasn't the best example, but we're going far in it. Maybe this was not the best approach. We should have done it the way maybe we did it earlier. But let's go. 4, this is what? 3 over 2 squared minus 12 times 3 over 2 plus 13. This is 4 times 9 over 4 minus 2 into 12 goes 6. 6 times 3 is 18 plus 13. 4 cancels 4. So it's 13 plus 9, which is 22. 22 minus 18 is 4. K is 4. So 3 over 2, 4 is my turning point. 3 over 2 is 1.5. So 1.5, 4 is my minimum turning point. That's that point there. Minus hk. We can put in, I've done this before, so I know what the answer is. When x is 2, y is going to come out to be equal to 5. And when x is 3, y is going to come out to be equal to 13. That would put me about there. So all I did in order to draw this graph, I tried to get some points. I started with the minimum turning point, which is 3 over 2, 4. Then I said 3 over 2 is 1.5. Then I found out what is y when x is equal to 2. When x is equal to 2, y is equal to 5. And I found out what is y when x is equal to 3, which is 13. So with that information now, I could draw a sketch of my graph. All right, it's only half of the graph because I'm using values of x greater than or equal to 3 over 2. I can draw the graph of y is equal to x because whenever I reflect the graph of a function in the line y is equal to x, I will get the inverse of the function. Right, so let us say this is y is equal to x. All right, so let's have our f of x and f inverse of x. On the f of x, I have 3 over 2, 4. I have 2, 5. And I have 3, 13. For f inverse x, the x and y coordinates are going to interchange. So I'm going to have 4, 3 over 2, 5, 2, and 13, 3. So I can plot those points. The first one is 4, 1.5, which is here. Then 5, 2, which is here. Then 13, 3, which would put me somewhere around there. It's literally not on my graph. And now if I draw my graph, it would look something like this. So if this is the graph of y is equal to f of x, this would be the graph of y is equal to f inverse of x. All right. Now, for f of x, the domain is x is greater than or equal to 3 over 2, and the range is y is greater than or equal to 4. For f inverse x, the domain is x is greater than or equal to 4. You should be able to see that for yourself. And y is greater than or equal to 3 over 2. Please note that for f of x and f inverse x, the domain and the range values interchange.